Good day to you guys. Today we're going to discuss how to set up ADC connections with FPGA Artix Edge A7 device. Um, so what we're going to do in this video is connecting the inbuilt uh, LDR and temperature sensors and reading their analog outputs and converting to a digital output and showing it in an LCD display. That's what our goal is in this video. Now we shall go into it. First, we'll go through the constraint file. This is a constraint file. We're using pin N11 JFNS or clock and transmitter, and these are the inputs of the LDR sensor, temperature sensors, respectively as C3, C2, B2, A2, C1, P1, E2, D1. In the board, you will be able to identify all these things, and we'll come into this part. This is very important for us. Get ports Vox 6, Vox 14, Vox P7. These are all the XADC file inputs, which we'll go in a minute. Now, here, this is the XADC file. In order to convert the analog inputs to digital, we need this IP catalog in order for us to transfer this data. Now I'll show you how to set up this file very easily. So all you need to do is All you need to do is go to this IP catalog and search for this XADC. This is the XADC visit. Now once you open it, it'll initially be like a single channel, nothing is selected. Now we're gonna use Vox 6, Vox 7 and Vox 14, Vox 15. So what we need to do is we should click simultaneous selection because we're gonna select multiple inputs for it. Now what we need to go is channel sequencer. Here we need to click Vox 6 and Vox 7 because those are the ports that we're gonna use. Now remember this, when you click Vox 6 and Vox 7, automatically Vox 14, 15 will get turned on. When if you want, you can just remove these alarms that are defaultly on. It's not required. Now if you click OK, it will generate this IP and then generate skip, etc. We can do it. Now we shall come to the code part. This is the sensor display code, which we have written in Verilog for easier understanding and easier implementation. This is the initial sensor display module where we instantiated clock, Vox pins, and then the LCD pins, and the 7-segment BCD display data. This is the wires for it. Registers to display the temperature and LDR values. This is the XADC Wizard Exchange instantiation, where we instantiated all different Vox pins and Vox ports and channel input, channel outputs, etc. And this is the XADC data reading block. Those are positive edge clock, the data 7-segment display will read it and multiply by 330 by 496. This is a conversion for us to convert this binary bits to a AXE value. This is a temperature binary RC value code. Then the temperature that is being in, like, this is a temperature here and LDR here. Now we want to convert this temperature binary value to ASCII value because that's how we display in our 7-segment display. So this is the binary to ASCII code conversion code, where 3-bit 00. We have used behavior modeling here. A positive edge clock sig B is equal to sig B plus 1. Temperature data is equal to A plus 8H30 and Q pin temperature Q1 by 100. This is general outline of it. And the same thing is applied for LDR values because LDR is also in binary values, so we have to do the ASCII values. Now we have got the RC values. Now we need to display it in a 7-segment BCD display. So we're going to instantiate first the LCD display. This will be our LCD display instantiation 8H38 8H0C for display on and off, and entry mode, clear display, etc. etc. This is a text that we are going to print on the BCD display. At the top of the line, we need to print temperature semicolon. So we're going to accordingly print the 8-bit hexadecimal values of temperature and this colon, and these two values are going to do. And then this is the light LDR sensor reading is light level, and this is text. This is the appropriate coding for it. And then the LCD control process logic behind it. This is the logic. Yep, that's about it for this ADC conversion. Now we'll go to the live demonstration of this code.
The code implementation in the Edge Artix-7 FPGA developmental board, where we've connected the temperature and ADC pin 3 pins together, seeing the LDR and the ADC 4 pins together. As mentioned in the code, this is the LDR sensor. Near to that is a temperature sensor which reads the current temperature values in the room. Now this is the BCD display which displays the temperature and light level values. Now as the temperature, the room is currently 30 degrees, it shows 30 degrees. Now the light level is currently showing as 20. This is the intensity of the light. Now at the same time, if I use the torch, for example, over here it drastically increases to 100. For the same time, if I remove this torch, it increases to 10 because there's very low lighting conditions. Same way if I keep my hand over here, it decreases to 0, 4, 3, etc. Now this is the code implementation of the ADC setup. If you like this video, do a thumbs up and do subscribe to our channel. Thank you. See you in future videos.